We finished last time talking about looking at this example of kind of consider one of the first of data visualization, information visualization, and it was Minard's March. You can see kind of the size of the army is how thick the river it is, and then it makes a pretty good point that that was a pretty big defeat coming back. And then we have the temperature also, especially here crossing the river. You can see even here, but there's a big drop right there. And the other thing, and it's going to be also, I'm going to try and emphasize this during the project for the whole semester, is we kind of we'll look at the proposals, we look at your progress reports, all of that. There are very few visualizations that are perfect. You can do everything with them. So they are designed for something. They're really good at making a point, like Minard's graphic makes a good point, that there was a big problem. The march was a disaster and they weren't ready for it, and so forth. Many times I say avoid, but many times you will. And during the project, I think many teams can be in this situation. You have your data have a visualization that comes up, and you can try to synchronize it with the task. So like I said, all those three things need to, your problem that you're solving or your task that you're trying to do, either way you look at it, needs to be synchronized with the data. If you have enough data for it, you have the data is sufficient, and with the visualization that you come up with. And that's why I want the task to be really think about exactly what we're seeing and what you can do in that visualization. And I say avoid, if you have a good task designed for it, but many times you design and then you realize, oh, this visualization can help me with that task, but what may not be the best. There may be ways to change it. So I need to try a different one. And I'm kind of trying to force you to try different things, because even if you're lucky and you get the perfect visualization the first time, you don't know that until you try a different thing. And you try a few things and it's like, okay, yeah, the first one was good, or maybe the third one that we got, or maybe we can combine some elements from this one into the next one. And so generally, things that visualizations tend to be made for certain types of data, and a lot of this class is the lectures are kind of, we'll start looking at different types of data as we go, kind of starting with lecture 3. We kind of vary different, look at different potential data types. Like, for example, some of the data that I pulled up right now looks more like a table, like a database, but other can be, what about networks? Social networks and stuff, they don't look quite like a database. They're slightly different. So it's a different type of data. It has some different underlying things. And visualization can work differently for that. We need different tools for it. The size of the data that we have, that you have, it's one thing to have to display only about 20 things. It's another to have to display 20,000. So how do we deal with that? So all of those need to be taken into account. The complexity, one way to look at the complexity is how many columns in my database. If I have just a simple time series, temperature outside, well, that's fine. I may have 20,000 data points, but it's just the temperature outside. But now if I start having the temperature, humidity, wind speed, wind direction, and it kind of adds up quite a lot for that. Oh, that reminds me, latitude and longitude, that's another type of information. So yes, networks are one, but what if it's more geographical? And data, so kind of both of them. And then the type of users that we can look at. Are they analysts, or it's like for a kiosk that you put in a mall? That's going to be different type of visualization, different type of interaction. So all of those. So that's kind of what I mean. There's no perfect visualization. And just to illustrate this point, here, everybody considers this a good representation, but here I have a question. Okay, I understand that Napoleon wasn't, or the army wasn't quite equipped for the cold, but was it worse where they were moving? Maybe they were, losing more people when they were moving, or when they were sitting in one place. Now, this one has no time attached to it. On those times, they have horses and carriages and people, and when you go, it's not like today you have drop-off of supplies. You have to go, sometimes you stop and go and gather, basically pillage around and gather supplies and move on and so forth. Repair what you need to repair. But this visualization doesn't tell me anything about that. Okay, so it can help me with some things. Yes, the cold seems to have been an issue, but it won't help me to answer that question, that more particular question. Was the cold affecting them more when they were staying in one place and resting and repairing, or when they were moving, marching to the next place, east or west? So to answer that question, I have this visualization. I kind of ran into it. I want to say that Tableau, this can be maybe the great-grandson of Tableau. I may be wrong. It may be a different tool that I think it's a different tool. Well, this was originally an academic paper. It came from a business school, and what they were trying to do is, at the time, figure out a way to automatically build visualization. Their idea was, if you give me a database, here's the visualization for it. And in the paper, they said because of Minard's thing, they collected the data and they put it in a database, kind of a number of troops, latitude, longitude, date, whatever the historical record is, they put it in a database. And then they ran their program on top of it, and this is in the paper. It's like, here is what the program came up with, how to represent that information. Okay, what are we looking at? Just it's about the same thing. The size here represents the size of the army, but as you can see, you can zoom in Blackboard, by the way. There's a zoom in feature. I know you can see it if you're not in class, but there's a plus and minus button that should pop up in the top left corner if you need to zoom into one of these. But you can see the dates on the x-axis, and then they have the longitude on the y-axis. So basically, Moscow is at the top, and then France would be here at the bottom, wherever I think they start when they cross into Russia. But the western, so west is here, east is up here. And you can see that the army went this way. So this is west to east, and then east to west is coming this way. Well, this maybe could help me a little bit with my question. It looks like at least it has the temporal data in it. So from that perspective, is that the best one? I don't know yet. I have tried others, but I'll make the case that probably it's not the best for my problem, but at least it allows me to maybe figure out what's going on. So as you can see, for example, something like this, it's kind of a continuous march. So you can see the time doesn't pass that long, and then their position changes. Here, it's a stop. The position doesn't change. but the time passes. So you kind of see this is kind of a fast march. They move quite fast after this. A lot of progress, almost the same at the same time. So that's kind of what you see. If it going, the more up it goes, the faster it is. Kind of, I can guess maybe even the velocity on this. So looking to here, do I see, now obviously this area here doesn't count because they split up. So I could maybe look in here. This is when they were staying, so right here. This is where they were staying in one place, and try to guess how small, if they lost a lot of people while sitting there. The other thing, while moving, then I can try and guess the difference between this one and this one here. Or maybe the difference between this one and this one here. That's why I said it's not the best way to do it, but at least it's there. I could zoom in and kind of use my fingers, kind of say, oh, is this smaller, is this bigger? Kind of go back and forth a few times. I'll take all the annotations out, so you kind of see it again. So is there a big drop in here versus here to here, or versus here to here? This is obviously moving, this is in motion, and this is staying. That kind of gives me a glimpse. Again, it's not the best. Why is it not the best? And that kind of takes me to a bar chart. Why is a bar chart so good? Because if I have two bars and they're sitting next to each other, I can see the smallest difference between them. If I have a bar here and a bar on the other side, not even aligned with anything, it's gonna, I cannot tell it. I mean, if there's a big difference, I will see it. I can distinguish a big difference. But if it's a small difference, nah, won't be able to do it. So that's, you can see that sometimes very, very small decisions in the visualization. I mean, consider a bar chart. Just if I have a lot of bars, and dot, 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 and I have a bar here, it's still going to be very not that easy to compare this one with this one. So considering what gets next to each other makes a difference. Maybe for me, how would I make this visualization better for me to kind of calculate? Maybe take the exact measurement here and place it here, kind of like a stacked bar chart. And that will tell me, I will see small differences. And then I could do the same thing, take this here and place it here as a line, a separate line, right next to it. Make it different color. And that will give me a chance, a better chance than what I have right now. Okay? So there's ways to improve even this one to satisfy my very specific, not everybody has the same question as me, the question. Before we go away from this, one more, I'll take notations out. So like I said, small design decisions will, and I don't have to rewrite the program, I can just add it to the database. So I'm not a programmer, I don't know how to code visualizations, but I can add that information in the database and say, this is a different type. This is the real data, now add another column and just carry over that and have the visualization. One other interesting fact here, the temperature is also shown in here. Color, you can kind of see it here. Temperature, but the color is red and blue. I was telling you that the temperature was really cold when they went there, and it kind of warmed up when they came back.
So the blue purple is warm.
Yes. Again, remember, these researchers, they were trying to make this program. So this is made without human intervention. They didn't tell. The program came up with it. They put a bunch of rules into how to build visualization from databases. I also gave you a clue. I know they were from a business school. So a negative temperature, a negative number, how do you put it? You know, if a company is making negative profit, how do you see it on a balance sheet? It's going to be red. So that's why this is very red, because the computer was made to understand business information. And then once the temperature defrost is above positive, it becomes positive. I think it's degrees Celsius there. Then you start to see blue. So that's another kind of interesting thing. Does it deter from the visualization? It's not that important, but it's just an interesting thing that human conventions sometimes are completely different. So positive versus negative numbers, something as simple, depending on the context. So if it's temperature, yes, you would expect it the opposite. But if it's your money balance sheet of a company, you expect they invert them. So that's, again, my point to, we can look at the same data, but we can come up with a slightly different visualization. And hopefully that's going to help you with the project. And in general, I can have the same data, but I can come up with, even if I don't want to touch and build my own code the visualization, I can just add a little bit more data into the fray, and then the visualization will pick it up and kind of put it next to each other, and it'll help me. So I can derive some information from what I already have in there. Also, kind of a famous one is this Florence Nightingale. She's credited to be almost the creator of nursing as a whole, profession. And again, this is also a morbid diagram, unfortunately. But let me kind of, locally, I'm going to zoom in. What you see here is, and the way I understand it at the time, this is the British Empire was fighting a war in Crimea. I don't know, either they were fighting the Ottoman or the Russian, somebody there. But what Nurse Nightingale did, she went, in front of the House of the Representatives in the British Parliament in general. I don't know which chamber, maybe both. And she was telling them we need to do better with the hospitals, because apparently in the front line, they would treat somebody with a wound, take the person out, put the next person in, don't even change the sheets. They would be on somebody's blood. And she was like, we need to do that. We need to have a nurse. The whole idea that we have to have a nurse. It's not somebody who needs to know that much about medical, but needs to take care of this. And she basically has the inner circle here represents mortality rate in hospitals in London, and then the circles here, mortality rate in Crimea. And you kind of can see that this is, I think it's October, this is September to October, well, actually November, maybe October, November, December, January, February, and the cold probably has something to do with it. But that's her point, is like, look how much, look in London, the cold doesn't matter that much, but then, what we're doing over there, it's not good. We're losing people for no good reason, soldiers. So that's kind of what we're seeing. I'll come back to this one because I think it exaggerates, maybe for a good reason, but it exaggerates the proportions. But we need to go through lecture 2 before I come back to this one. The next few things. I wonder if I should stop. One thing I can do is start and stop recording every topic when we change topics, even in the middle, rather than have a long one. But I don't know. I'm worried I'll forget to start it.
I couldn't understand what you were saying. What's tarantula?
Oh, tarantula is the best thing ever. It takes forever to explain, but once you understand it, it's actually pretty easy to use. It's one of those things. It's like tic-tac-toe.
Oh,
But yeah, from the slides, it's not going to be easy to understand what it is. The main reason I have kind of here is other types of visualization. So some examples. I used to have a whole lecture on text, but I never get to it. I haven't updated it in forever because I never get to it. By the semester ends, and so I figured I'll pull some text visualization off here because that's something interesting. A lot of times, just not having to go through text is helpful. Text takes time to read. So I have these three examples here: tarantula teamscapes and this Twitter GIS thing. So let's do tarantula first. So yeah, it's gonna be hard to figure out what is this? Well, it's a tool to help people debug programs. What we see here is that the program, each line of code like this, 2 lines of code, they're here somewhere. I'm not exactly sure where, but somewhere maybe in here. We can see them. So each line of code is just a pixel wide, tall, I guess. But the line, the indentation, and the relative length is maintained. So everything you're seeing here is code, computer code. You can see probably this is a for loop of some sort. So all of that is computer code, and it starts here and it keeps on going. Once we hit the bottom, it goes back to the top. This way they can use the whole screen real estate. And so that's kind of what we're seeing. So first of all, I see the entire code. And the one way they were debugging it was more or less automatically, semi. And I think I was at the presentation when they did this, and I think this was some piece of code that was supposed to run on a satellite from the European Space Agency, and they kind of put it out there for people to play with it. So the way this works, they will put some inputs to this piece of code. They will simulate inputs to it, and then they will see the reaction of the piece of code. They were supposed to, I don't know, keep the satellite from spinning based on the inputs. So right here, you can see that they have 300 inputs that they place. So they have a suite of inputs, and they run it 300 times with 300 different inputs. And then 66 times, the code didn't do the right thing. It would have crashed the satellite. It would have caused something. So that's kind of one way to test software. You just plug in inputs to it and see if it reacts properly. And like I said, this case, 300 different executions. Out of those, 66 did not run properly. And here is how they kind of start. So first of all, they kind of use all of this to give you a big bird's eye view of the code. And then they use color to give you a bird's eye view of what's happening. And they use the color in the following way. You can see that some lines are gray. And by the way, one more thing for those of you who are non-programmers, but it's kind of an intuitive. In computer, it's unintuitive actually. There's a saying in computer science, sometimes it goes with 80-20, sometimes it goes 70-30, but it basically says that 70% of the time, only 30% of the code gets executed. or 80% of the time, only 20% of the code gets executed. There's a lot of code in there that doesn't get executed. Why? Because it deals with things that don't happen that often. So I'm running Chrome, whatever browser you're running right now. But when your internet fails, Chrome has a page that displays something that says, hey, no internet connection. Same with Firefox. Well, guess what? Somebody had to write that code to print or to draw that particular thing that tells you there's no internet connection. That code is not going to run all the time. If there's an internet connection, it doesn't get to run at all. So Chrome is not going to display that and take it out quickly. No, it's just not going to display it. So that's kind of the thing with code. We end up writing a lot of, you have to think of a lot of situations that only happen rarely. So that's the reason why the saying, which is really true, any non-school piece of code would have lots of code to deal with things that could go wrong. So how is the color used here? Everything that's gray never was executed. So out of the 300 executions, the gray stuff never got a chance. So is there an error in there? We don't know, but it's definitely not what's causing these 66 executions. So the duller, the more gray the color is, so that's kind of an extreme. At the other extreme, you can see there's some really bright yellow and some really bright green here, some really bright red. So the more color it has, the more time that particular piece of instruction was executed. Okay. If it's somewhere in the middle, like this one, it was executed once or twice, but not all the time. So that's kind of where it gets. So the whole idea that the brighter it is, it's in your face, the more it's been involved in these executions. And finally, the color, as you probably guessed by now, red, it means this has been executed every time the code failed. Green means this has been executed every time the code performed correctly. And then yellow is it's been executed both when the code failed and when it was corrected. So now, where would I start? Just, again, it takes a while to explain, but once you know what you're looking at, you kind of see this line, this particular line failed 3 out of 3 times. So it was executed 66 times out of 300. So not all the time, so it's not very bright. But every time the code failed, out of the 66 times, the code failed 3 times. And every time it failed, this line was executed. Okay, so that kind of gives you an idea where to start debugging. So you run this suite of tests, and then you look at your code and say, hey, I will start with bright reds and see why. Because they were always executed when the program failed. Or I will probably ignore everything in green. Because when it's green, it means every time those pieces of code was executed, the program did the right thing. So can be a problem there. And if I can find it on the red, then I'm probably going to start looking at the yellow. Because yellow means it's been executed, both when it failed and when it ran. So it may be a problem here, and then it's sending it, it's picking up the wrong, because when the program runs, you have it branches. It may go one decision or the other. Maybe here they take the wrong decision in the yellow. It's not guaranteed that all the errors are going to be in the red. Maybe the problem happens here in the yellow somewhere. And then they make the wrong decision, and that's why the program failed. But it just gives you a way to start debugging. Look at bright reds. If you don't see it there, look at yellows. And definitely the grays have nothing to do with this error. There may still be errors in there. And also the gray tells you those lines were not tested by these 300 executions. So we have to do more testing if we want to put it on satellite to make sure that everything gets included. So it gives a pretty kind of good, maybe a program manager from the European Space Agency will look and say, okay, well, I see there's problems, we need to fix them. But you can also, even if all of it is green, you can see, oh, but there's some grays, so we need to do something, because I can send it without testing those lines of code. What are they doing in there? So like you see, you can use them for a few things, but it's just a one view of everything, looking at text. The other, so that was Tarantula. This one is, I forgot the name. Well, so Tarantula looks at programs, it's text in a way, but this one looks at, and I actually haven't tried it. Let's see, this semester. Sometimes it lets me click on it. Not this time. Let me go back. Well, so the next topic, when we're dealing with text, we may have a collection of things. It can be a collection of documents. It can be a collection of social media posts. So some things can be longer than others, but it's a collection of news feeds and so forth that we want to look at and kind of see what is, the predominant thing, or even look over time. Over time would be an anime. You build it for each snapshot. It's not built in necessarily into this. So what we're looking at here is something called a self-organizing map. And what they're trying to do is have things that are related to each other close on the map. So this is not a real map, obviously. It's just built to keep the topic. So for example, here on this island, you can see that intradermal, which is probably needles, is related to hepatitis B. So these two topics are related. I have something blocking my... Sorry, I have to go back and forth. I had a pop-up I couldn't get rid of. And measles vaccine, rubella, health program, all of those, they tend to be next to each other. HIV close to AIDS, and so forth. So that's kind of the idea. How do they figure out that the topics are related? Because they kind of show up in the same article. But for example, if there is, and they see the occurrence. So first of all, that's kind of, they do that. But there's a few more things that you need to consider when you look at collections of documents. And one of them is kind of like the base. There's some things that appear in a lot of places, but it may not be that the document is about them. Think about news. If it's a news article about, let's say, Ford, now the name Ford will show up, car will show up, things like those many times. But maybe there's a paragraph at the end that just mentions, President Trump, policies, blah, blah, blah. So President Trump may show up in that because he's the president. May show up in that article, but that article is not about President Trump. But when there's an article about, take another car company, Tesla, also President Trump shows up, maybe just a footnote, and then there may be an article about Trump itself with a lot of connotation. So what I'm trying to tell you is that there are some terms that show up a lot, but they're not what the article is about. It's kind of like a base. And there are some terms that show they're very focused on that article. So that's kind of where you're seeing all of these variations in here. So not only things are next to each other, hepatitis B and intradermal are next to each other, but the size of their, you can see liability is also put in here somewhere. So it probably happens with healthcare providers if they get stung by a needle and they can get infected like a nurse by mistake. So it's liability for the employer. So it's not only how many articles are there, but what is the base of that article. So you see, this is a big island. So it not only that they're put together, but they decide how big each topic is based on where is it covered. So that's one way to do it. And the final way they're kind of dealing with this is, for example, here with varicella, you can see there's a lot of articles next to each other, very focused on varicella. You can see the focus right here. And then with the hepatitis B, they're not as focused to each other. So all these data points, the dots, also offer you kind of an idea of how dense it is. So the size of the island, the green part, tells you how big of a term that is. It shows up in other places, but not necessarily. And then the dots themselves give you another clue on how focused and how dense that is. It's like I have a galaxy, but how many stars are in that galaxy? I can have a galaxy that's very compact with lots of stars and has the same size as one that's kind of spread out with very few. And that kind of helps to put the dots. So that's one way to visualize. So all of these are providing some, again, you can see that AIDS is very focused here. And over here it says top 10 of 74 documents. So this is analyzes 74 documents about, you can kind of see some medical things. I used to have, well, I'm not sure if I have that example, but so this carrot search, they're providing text, not analytics, not only visualization, but part of it is visualization of the text analytics. So like I said, collections documents are a whole different animal because you have this idea of terms, how many you have, how focused are they? And that's kind of what you see. Related to that is the idea of making it in 3D and kind of remember the base. And that's not necessarily, here it kind of, they explain what it is. So the peak height is proportional to the cluster's internal similarity. So if it's really high, that would be the equivalent of the dots being close together in the previous visualization. Grayscale, proportional cluster internal deviation. So here they're using color and kind of see how much articles differ from each other. And the peak volume, so the volume itself to the number of elements in the cluster. So the volume gives you how many articles are there. I don't know what the height, the height, they said peak height cluster internal. So this cluster is not very similar. Network wireless commune, not very similar, but this one, bank loan deposit, very similar article. So you can use different metrics to put in there for this. And this is kind of the 3D version of it. Here's an older thing from, this is from the Pacific Northwest National Lab. I think they are doing visualization for the government. Like government entities can contact them, agencies, and pay them to do custom visualization for them. So this one is showing news articles. And then you can see it's kind of a little, like I said, a little bit older news. But you can see that Labour in Common, which is in Britain, is close to Europe, close to de Gaulle, France. And then Egypt is here and Syria is close by. And then it kind of moves towards them Buddhist with I think that's still a Lao, maybe, I don't know. But in this case, the base of the mountain kind of tells you how much people are like Trump, because he's the president, be a lot of base there. A lot of articles would mention him, although that's not necessarily about him. And then the top is, how many of those articles are there. So, but you can see there's variation. You have to decide how to create these. The bases are probably self-organizing maps, and then what you do with the 3D, you kind of get those peaks in there to show. And the final one, this is something we've done here. I mean, I've done with my students. We were at some point got some relationship with the Air Force Research Lab in Dayton, in Ohio. And one of idea that they gave me, they were like, okay, it's the Air Force, so we're flying all of these sensors all over. Remember, at the time, there wasn't a Space Force, so even satellites would fly. So they have sensors, infrared sensor, imaging, all of that. And one of the questions they had at the time was, what if we see a group of people? What should we do? Like a big mob of people. Should we send somebody or not? So I don't know. One reaction we had was, what if we look at Twitter? And if we see happy and Chinese New Year and it's nothing. But if you start seeing fire and explosions and injuries, then you have to send help, send ambulances there. So that was, how do we put that on a map? How do we put Twitter on a map? So that's the whole idea here. And
So the dots are more people in a location.
no, I'll explain in a second. I have a video for this. So this one, video is worth a lot more words than my words. So you see it in action. Okay, so share my screen. Just needs 20 clicks to go there. No, I'm exaggerating, but it's just a lot of clicks. And this one should be on lecture 1. We called it BuzzViz, kind of what's the buzz, what can we look at? Obviously, we didn't have any classified information, so we put it on top of kind of GIS data. We found that NASA has something like Google Earth, written in Java, open source code. I forgot, Whirlwind used to, maybe still called Whirlwind. I looked at it a few years back, and it was completely changed. It was still open source, but it was not what we used in terms of code. So we call it, you see, Twitter on Whirlwind. How do I make it fit? I don't know. The problem that we had is a few problems. First of all, at the time, at least, Twitter didn't have that many location markers. So we tried to kind of figure out the location based on the context. Problem number one, that's not visualization. That's not going to spend more time on it. But even if I had the exact location, and let's say New York, what's on this map right now? Can't tell the city. I don't know what the city is here, so can't read it. But let's say New York, there's maybe 20, 30 most frequent words, but I can't put those words on top of each other, the exact position, because nobody will be going to be able to read them. So what we've done, we actually spread them out. we kind of put them in a circular pattern. You would be able to make it out at some point. Maybe here, you can see there's a word in the middle, and then there's one around it, and then there's another. So really, all of these words are probably geolocated right in this area. And at first, it's like, oh, you don't know what you're talking about. But if you're interested, if you see something, there's two ways. You can navigate using, we didn't introduce any more, very little interactive new stuff to do. So if you're interested in something, just go fly over New York. And that's, you're going to see some of the flying happens just like Google Earth, like you do on a GIS representation. So the other thing that we can do, notice that I can click on a word and it tells me where it's being tweeted from. So I can go the other way. I can see its location. But then if I'm interested in a particular area, I can zoom in and out. So that's kind of coming out all the way from this is probably the biggest view. There's maybe two of them, the whole United States. Now, that is the whole United States. So it's almost like a query. We can query all of that. I don't know what happened there. That's not right. Okay, maybe that will make it easier. Oh, open image. No, I don't want the image. Doesn't feel like it's the whole, it was longer when I uploaded it. So every semester, this is in Kaltura. Okay, I think this is from the beginning. Somehow I moved it. I don't know how. So that would be kind of the normal way you start with it. It's a Google Earth thing. Obviously, jobs, definitely the most tweeted thing. But if I'm interested on something, I can just go in that area and kind of zoom in towards it. And here I'm getting lost in the video. I was doing it on a underpowered laptop, and with the Whirlwind is not the most efficient thing. It's freeware. So, and then adding all of that and querying Twitter and querying a database of Twitter things. So you can see that that particular word jobs, where it's coming from, school, it's right there. It does have a 3D, a built-in view, and those look pretty, those markers look pretty nice in 3D. And then I'm going to get lost in Mexico because the computer was just it was very not as smooth. And then I'm kind of coming back. You can see them on the horizon, the white cones. So that's very different versions. Like I said, I don't know how this thing is built into Blackboard, or it's a partner Blackboard, Kaltura, where you upload the videos, but it just every year it changes something. Every semester it changes something. Right now I can't see the controls to go forward and backward. Like I said, at the high level, there's way too much noise in terms of jobs and things like those things. But once we zoom in, you start seeing kind of interesting stuff like flying over Nashville one time, it was like library flood, and the library was flooded by a storm. Then you can see small accidents like a ferry boat somewhere. 2 people got injured. The funniest one was we saw couch, fire, garage,
Couch fire.
and garage. So somebody set a couch on fire on the garage. We did look for the tweets necessarily, but it was right there. And fire department did something. So there's a few things that we can kind of get from there. And this is stopping it. And again, I hate it that I can't go back. Where are my controls? I don't know. The other thing that we were doing, just to look for time periods, we were starting to use different sizes for the fonts that we're displaying. Go back. And the font will, every hour will get smaller if that topic disappeared. So if it was something that was going on, it will stay, and then they will get smaller and smaller and smaller. A new one will pop up. So we kind of have an animation on it. Explored a few things. But that's pretty much, I think you got the idea here. And we could tell, that was around in Denver, I think, with the couch. The funny part is there was another fire about 2 hours later, because we could see, once we did the animation, we saw the couch fire went away, and there was another fire, but that was like at a business. They started disambiguating between the two. And I'll go back to the slides, but I think we're running out of time. Yes, let's stop here. It's a new topic that comes up next. And I don't think I have time to cover in the next 3 minutes or so.